Now, what we are going to cover in this lesson and the upcoming lessons are those objects we just mentioned. Now, those objects are query reference objects and snapshot objects. We'll also talk about security rules near the end about how to protect the data that we're passing into our database, but after we've fundamentally understood both the query reference object and the snapshot objects. So what are query reference objects and snapshot objects? Well, we can only get these types of two objects whenever we make a query to Firestore. And a query is a request we make to give us something from the database. So whenever we ask for something to the Firestore library from the database, what we will get back from Firestore is one of these two objects. Now, of these two objects, both of them can either be of a document type or a collection type. What this means is that we can either get a document reference object or a collection reference object, or we can get a document snapshot object or a collection snapshot object. But that collection snapshot object is called a query snapshot. That's just one thing to remember. Firestore will also always return us these objects, even if nothing exists in that query. So what do I mean? Well, we will see that in the example, but let's just define these objects first. Now, we'll start with the reference objects. Query reference object is an object that represents the current place in the database that we are querying. So in order for us to get a query reference object, we do it by querying using one of these two methods. And again, we query either a document or we query either a collection. And we do it by calling firestore.doc and then passing it the path to that document, such as user / and then the user ID. Or we get it at a collection path by calling firestore.collections and then the path to the collection / users, for example. A query reference object does not have the actual data, though, of either the collection or the document. It just represents the place in that path in our database. For us to actually get the properties or the data that is related to the Firestore, we have to get the snapshot object. And we get that using the reference object. But we'll talk about the snapshot object after we finish exploring the reference object. Now, as I mentioned, there are two types of reference objects that we can get back. There are document reference objects and collection reference objects. We use the document reference object to perform CRUD methods, which are the create, retrieve, update, and delete related methods on that document in our database. Now, the methods that we need to call on document ref are .set in order to create it, .get in order to retrieve it, .update in order for us to update the data, and then .delete for us to just delete that entry entirely. Now, we can also add documents to collections using the collection ref, as long as we use the method .add on that collection ref. So as you can see here, if we call collectionref.add, and then we pass in an object with the value props of what we want to add as a new document to this collection, collectionref.add will do that for us. We also are able to get our snapshot objects from these reference objects by calling the .get method on either the document ref or the collection ref. And the document ref gives us back a document snapshot object, whereas the collection ref gives us back a query snapshot object, which I also call a collection snapshot object. Now, we get these snapshot objects with our get method, which is equivalent to the retrieve method in the CRUD paradigm. If you're unfamiliar with CRUD, CRUD is the main way that we interact with our database, which is through these create, retrieve, update, or delete methods that exist on our reference objects. If this paradigm concept seems a bit confusing as to why it is this way, it is easy to find articles written about this extensively because CRUD has been around for quite a long time and it's a pretty popular paradigm of working with databases. But moving on to the document snapshot object, that we get from our document reference object allows us to check if a document exists at this query using the .exists property, which gives us back a Boolean. We can also get the actual properties on the object by calling the .data method, which returns us a JSON object of the document. So what we'll do is let's just take a quick refresher about what we were doing way back when we set up our authentication and storing our authenticated users in our database, because we actually saw those objects when we did this. Now, what we did was we used the auth library that we got from Firebase, and we said whenever the authentication state changed, we want you to pass us the user auth object, and then we will listen for all of the user auth objects that auth state change will give us. That user auth object is stored, if you remember, inside of a different database than the one that we have. It's in the authentication table. Whenever a user signed in with email or password, or our Google sign-in, the authentication would store that user's information, and then it would assign a user ID to it, called the UID. And what we did was we would pass that whole user object with that UID into our create user profile document method. And inside of that method, what we did was we would essentially use the user auth object to query our database for a document reference object, as we see with our firestore.doc. We would say our users collections / and then the user ID that our authentication library assigned for us, which was this ID. Using the user reference, we would then call .get to get the snapshot object, because as you remember, even if we did not have an actual user object in the database, Firebase will always give us back a snapshot object, because using it, we would check whether or not it exists or not using the .exists property, as we just spoke about. Now, what we did was we would say if the snapshot, right? So if the snapshot object, if the document exists, then we don't want to do anything. But if it does not exist, then we want to create a new document object inside of our user ref, which is why we say userref.set. By saying userref.set, we're saying I want you to create a new document using this object with all these properties on it inside of our database. And that's exactly what we did. And that's how we were able to create those users. That's how these users in our database is generated. Now, we can actually walk through this in a more comprehensive way. Let's first console log this out. As I mentioned, Firebase will always give us back the reference object and the snapshot object, even if nothing exists there. So instead of using our user auth UID, let's use something completely random that I just made up just now. If I save this and console.log the user ref that we get, right, we know that our authentication state updates because our application always keeps track of whether or not our user has signed in before or not. So even though our application refreshes, we are still getting the authentication state update to us. So that will trigger what we just console logged. And here we see our document reference. We see the ID is the made up ID that I had. And we see the path that we passed to the firestore.doc call right here. That's what it's giving us back inside of our document reference object. But we know this object can't exist because if we look in our database, we see that we only have these two, not the made up one that I just made with the 1, 2, 3, 0, 6, whatever. Now, this is good for us because we don't want Firestore to error out if we don't know if an object exists or not, right? In a way, it gives us way more flexibility in how we do things. But at the same time, we do have to code with this in mind. So what we would do is we would get the snapshot using that user ref, right, that we just made. And then what we can do is we can now see whether or not the snapshot exists, right? We can see what's on it because we know that Firestore will still give us a snapshot object. So now if we look back, we'll see that the second object is our document snapshot object. On here, we see the exists is false because as we know, no such object exists. We also see that the ID is the one that we just randomly generated because Firebase uses the ID path that you provided it, right? So for us, it's the path that we randomly wrote as the ID of the document that you're trying to get. But now let's actually test this code that we wrote. So we know that our snapshot does not exist. So we know that we're going to create a new object in that user ref that we got, right? And let's manually set display name to something new like test user. Email can be random email at gmail.com. Created at will be the create at, and then we don't have any additional data, so it's not relevant. But now if we save, we will see that our new object actually got created in our Firestore database. If we check, we'll see now that in our users, there's that user we just made. We just created this user with those properties that I just wrote in. And this is just because of how userref.set works, right? We're setting that user object using these properties that I want. But this is the main thing we can do with both our userref object, but also our snapshot object. Our snapshot object, now we know that our snapshot exists. We'll also see that what we're able to now see on our snapshot object, if we refresh, we'll see that we actually have access to this .data method that will return us the data regarding our snapshot. We actually couldn't see it in our console log, but if I just call data like this and save, we'll now see an object representing the user that we created. And that's how we get the values of our documents. We have to call .data on that snapshot object. But hopefully now you understand what the document snapshot object and the document reference objects are respectively used for. And we'll definitely explore more of using those because it's the key of how we're going to build and pull data from our database. Now let's talk about collection snapshots, or as they're called inside of Firestore, query snapshots.